in this question, it gives us this reaction, and then it tells us or asks us to assume that this reaction or process proceeds by a simple one-step reaction. In other words, this reaction is the rate-determining or slow reaction in this process. It then asks us to derive a rate law for it. Now, I told you in some earlier videos that a rate law for any process is going to be equal to some rate constant multiplied by the concentrations of its various reactants raised to some exponents m, n, o, p, whatever, for however many reactants are there. I also have told you in earlier videos that these exponents m and n have to be determined experimentally and that they are not necessarily the coefficients in front of the reactants in the balanced chemical equation. I have told you that, and what I said was actually true. In this lecture, however, I've given you some additional information. That information is this. For processes, there are often or can be 2 or more steps that the reactants traverse in order to convert to products. Whichever of those steps happens to be the slowest is the rate-determining step. As it turns out, if you know which reaction is the rate-determining step, which one is the slowest step, then the rate law for that one step actually is equal to the concentration of each reactant with the exponents here being equal to the coefficients. In this case, it would be 1 and 1. Hopefully that makes sense. So what I told you before wasn't a lie. We just now have a little bit more knowledge and information. Once again, if you have the specific stepwise mechanistic reaction that you know is the slow reaction, then m and n actually are equal to the coefficients in front of the reactants in that reaction. Now, if this process occurred by multiple steps, then what we'd have to do is determine which of those steps was the slow step, and then we could derive the rate law directly from that step. So this is the correct answer to this question.